Hi, this is Mr. Anderson, and today I'm going to show you how to do mole conversions. Sometimes we call these mole-gram conversions, but the first thing kids get confused by is just the word mole. I know it's a furry animal, but the mole comes from the word molecule or the root molecule. And so if you think of it that's an easier way to kind of get at it. Why do we even use it? Well, the reason we use mole is the mole allows you to deal with chemistry. It allows you to deal with atoms that are really, really small in the laboratory. And so the nice thing about a mole is it gives you a usable amount. You can kind of think of it that way. Another way to think about a mole is it's simply a unit. And so if I say I need a dozen eggs, you're not scared of the word dozen. It's not very scary. And you shouldn't be scared of the word mole. All it is 6.022 times 10 to the 23rd. So it's a number. And so by the time you're done with this, you should be able to take the amount of water inside this beaker. Looks like we have about 200 milliliters and thereby 200 grams of water, and you should be able to figure out how many molecules of water are actually in that. So let's get to it. Let's start by talking about eggs. And so a dozen is simply the number of eggs. And so if you have a dozen eggs, you know that 1 dozen is equal to 12 eggs. And so when you're dealing with a mole, it's the same way. It's just going to be a number of atoms or particles that you have. Also, you might know that a dozen of eggs weighs 24 ounces. And I didn't know that, but I learned this while making this. If you get large eggs at the supermarket, large means that every dozen eggs weighs 24 ounces. And if you go to extra large, that's 27 ounces. So if you're getting grade A, large eggs, if you take a dozen of those, that's going to be exactly 24 ounces. And so what we could do, and you should be able to do this in your head, is you should be able to go from eggs to dozen to ounces. In other words, if I have a dozen eggs, how many eggs do I have? Well, you'd simply multiply this times 12 when you run in this direction. And if I have 1 egg, how many dozen do I have? Well, you're going to divide by 12 as you go in the other direction. And likewise, if a dozen eggs weighs 24 ounces, you're simply going to take it times 24 to figure out how many ounces you have. And thereby, as you move back, you're going to divide by 24. And so if you think about this example when you start talking about moles, the next slide shouldn't be scary at all. If I were to say to you, let's say I have 48 ounces of eggs, how many eggs do I have? You should be able to figure out that that's 24 eggs. Okay, so let's go to the next slide and you'll see that it's not really going to change. So what is a mole? A mole is simply a number, and so it's 6.022 times 10 to the 23rd particles. The other thing that you need to know is how much a mole actually weighs. To figure out the mass, just like we said, 1 dozen eggs weighs 24 ounces, 1 mole always weighs the formula mass. And so if we're dealing with H2O, for example, how do I figure out how much a mole of water weighs? You're going to have to figure out, as I make my H correctly, you're going to have to figure out the molecular mass or the formula mass of that. And so let's go forward for a second. So if we're on this screen right here, I have to figure out H2O and its formula mass. To do that, well, H2O has 2 H's, so I've got 1 H, 2 H's, and then 1 oxygen. And so on the periodic table, you're going to find the mass of each of those. So here's hydrogen, and so it has a mass of 1.01. The other hydrogen has a mass of 1.01. And then the oxygen, which is way over here, has a mass of 16.00. And so if I add all those masses up, the mass of water is going to be 18.02. And so if we wanted to say how much mass does 1 mole of water have, it's going to be 18.02 grams. And so you'll have to do this if you're ever going from moles to grams. You'll have to get a periodic table out and you're going to have to figure out what's the formula mass of that. And so let's go back to this then. So just like we could go from 1 egg to the dozens to the ounces of eggs, we can go from particles, and that could be either atoms or molecules, to moles, and then finally to grams. 1 mole is going to have exactly 6.022 times 10 to the 23rd particles. And so if you wanted to go from moles to particles, you'd simply multiply it times 6.022 times 10 to the 23rd, just like we did with a dozen eggs. And thereby, if you want to go from particles back to moles, then we're going to have to divide. And if we want to go from moles to grams, we're going to have to multiply it times the formula mass, or the mass of that molecule or atom. And then if we want to go back, we're going to divide it. And so those two strategies will allow you to make these kind of work. But I always want you to understand how to do this using factor label method. And if you don't know how to do that, make sure you look at the video on how to do factor label. So let's do some actual problems because that's what you want to know how to solve. And so let's say we have this. Convert 0.200 moles of H2SO4 to grams. And so if I go back and figure out where am I going to go, well, right here they're telling me I've got moles and I want to get all the way to grams. And so which one of these am I going to use? We're going to use this first conversion. So where one mole is equal to the formula mass. So we're going to use that conversion right here. So let's go forward. So if you're ever doing factor label, I always tell you, remember, write 0.200 moles over 1. And now I'm just going to multiply it times a factor. So I want to get rid of the mole, so I'm going to put 1 mole on the bottom. And then I want to get to grams is my goal, and so I'm going to get to grams on the top. So I want to find that conversion between moles and grams. And remember, 1 mole of anything is the atomic or the formula mass of that. And so we have to figure out H2SO4. So let's go find that. So H2SO4, as I find my periodic table, and let's switch colors. H2SO4 is going to have 2 hydrogens, and so there's 2 of these 1.01, so that's going to be 2 times 1.01, which is equal to 2.02. Also in H2SO4, let's write that down here, H2SO4, we've got 1 sulfur. So I find sulfur on here. Sulfur has a mass of 32.06. And then we've got to figure out, I've got 4 oxygen, so it's O4. So I'm going to take 4 times oxygen, and oxygen is 16, and so 4 times 16 is 64. So I have to add all of these up. So I'm going to take this to, excuse me, this is an 8, this is a 0, this is a point, and this is 98.08. So this is the formula mass of H2SO4. And so once I've got that, let's go to where our actual problem is. So we've got 98 point, let me go back, I forgot it, 98.08. So I have 98.08 grams in 1 mole of, this is sulfuric acid. So now I just am going to multiply that. So I'm going to cross off my moles, get rid of my moles, and so now I've gotten to grams. And so now if you look at it, I'm just going to take 0.200 times 98.08. So let me grab a calculator. So that's going to be 0.2 times 98.08, and I get 19.616. So let me go back to the presentation, 19.616. And so it's 19.616 grams of H2SO4. Okay, now let's do significant digits. This has how many significant digits? 3, and so this would not be the correct answer. Correct answer would be 19.6 grams of H2SO4. So that's going from moles to grams, and we just simply multiplied it by the number of grams. Okay, let's go to a little bit harder one. This one we're going to take 102.8 grams of water, and then we're going to figure out how many molecules that is. So if we go back to our little chart, they're telling us now how many grams we have, and we have to go all the way over here to particles. And so I'm going to have to use both of these conversions. This conversion is going to get me from grams to moles, and then this conversion is going to get me to the actual number of particles. And so let's take a stab at that. Here we go. So first thing I'm going to do is I'm going to write out what I start with. So that's 102.8 grams, and I'm going to put that over 1. This is H2O. Now I'm going to multiply that. So I'm going to multiply that times, I'm going to put grams of H2O on the bottom because I want to get rid of that. And I always have to go to the mole. Mole is always going to be in the middle, so I'm going to put moles on the top. I know 1 mole, and we've already done the water one, H2O. We already said that that is 18.02 grams of water. So now my grams of water would cross out. And now the next thing that I want to do is I want to go from here, from moles to molecules. So what's my conversion to do that? 1 mole of anything is always Avogadro's number, so 6.022 times 10 to the 23rd of molecules. And so now my moles will cross, and I love factor label because you can always look through and make sure, yeah, I'm getting to molecules, and that's what the question is trying to ask. And so if we do that on the calculator, let me switch to a calculator. So we are going to take it is 102.8, and I'm going to multiply that times Avogadro's number, which is 6.022. Oops, I screwed up there. So let's try that again. So it's 102.8 times 6.022. I love this key right here. What it does is allow me to write in what's the exponent. So it's times 10 to the 23rd equals that. And then I'm simply going to divide that by 18.02. And so the right answer for that is 3.435 times 10 to the 24th. 3.435. So that is 3.435 times 10 to the 25th. Let's do significant digits. This has 4 significant digits, and so that's going to be my right answer. And so that's going to tell me how many molecules of water we have. So if you want to go back, you could go back to that picture I had right at the beginning, and you should be able to figure out if this is 200, let's say make it harder, 200.0 grams of H2O. Could you figure out how many molecules that would be? If you were paying attention, you should be able to. And I hope that's helpful.